Very well. Okay, friends. So on today's show, we break into the study of area, which is somewhat important because we haven't considered area yet at all. It has been strangely absent from our study of geometry, but if you study geometry in grade school or high school, eventually you hit some discussion of area and what it is and how it works. So we have to deal with that. And so here comes the seventh axiom that Venema gives to us. It is called the neutral area postulate, and it says, associated with each polygonal region R, there is a non-negative number alpha of R called the area of R, such that the following conditions are satisfied. If two triangles are congruent, then their associated triangular regions have equal areas, and if R is the union of two non-overlapping polygonal regions R1 and R2, then alpha of R is alpha of R1 plus alpha of R2. So what is a polygonal region? Well, a polygonal region is any region that can be broken up into non-overlapping triangles. So we could extend this segment, and then we could connect the dots up to there and get three different triangles. Now, mind you, that's not the only way to triangulate the region. Let's copy this. I could have triangulated the region by saying let's extend this down and then connect the dots over like this and gotten an R1, R2, and R3 that way. The point of the matter is if I have a polygonal region, it can be triangulated somehow. Possibly more than one way, but somehow there exists a triangulation. And once there exists a triangulation, well, then we go back to properties of triangles, and so that's why we deal with two triangles being congruent. If two triangles are congruent, then their associated triangular regions have equal area, and if you were to bring together two non-overlapping polygonal regions, then add the smaller regions together to get the area of the bigger one. This will be true in neutral geometry. It is true in Euclidean, it is true in hyperbolic, it is true neutrally. So if I have some convex quadrilateral as a polygonal region because it can be triangulated like so, add up R1 and R2, get the area of the whole thing. Likewise, let's move this over. Likewise, if I have some triangle and I pick a point on one of the sides and connect the dots, R1 plus R2, the area of R1 plus the area of R2 is the area of the entire triangle. Those are truths you're going to need to hang on to because, well, that's what all our area discussions are based on. The idea of triangulation becomes a key because we end up taking every polygonal region and triangulating it somehow and moving the triangles around into shapes that are more familiar to us. So keep that in the back of your mind. Up next will be area in Euclidean geometry.